Hello, my expert chemists. Last time we talked about 4 variables that you can measure for gases. So to review those, temperature is capital T, volume, capital V, pressure, capital P, and then amount of the substance, which is lowercase n. And it's measured in moles. So we are going to look at a series of 4 different gas laws. And for each of these 4, we are going to hold 2 of these variables constant. We're not going to change them. And holding those 2 constant, we're going to look at the other 2 and their relationship to each other. Now, it's important to know that these relationships only exist if you are holding the other 2 constant. So the first one that we're going to look at is Boyle's law. So Boyle's looked at pressure and volume and their relationship. So he held temperature and amount constant. So for each of these, we are going to do a little demo. And then we're also going to look at what the law says. So I have 2 marshmallows here. And I'm going to put one of them in a vacuum pump, and the other one I'm going to leave out as reference. So let's take a look at our vacuum pump here. So this right here is called a bell jar, and it is connected to my vacuum pump here. So I'm going to put one of these marshmallows in here. Hopefully you'll see it. Stand. And I'm going to leave the other one outside for reference, and I'm going to turn on the vacuum pump. And what a vacuum pump does is it removes some of the gas particles that we have inside. And so when it removes some of the gas particles, it decreases the pressure. Now I chose marshmallows. You know, marshmallows are pretty fluffy, right? Because they have air pockets inside. So these air pockets obviously are gas particles, and so that's why this applies. So the gas laws obviously only apply to gases. So hopefully you can kind of see that as my pressure is decreasing inside of my bell jar, my marshmallow's volume is increasing. The air pockets inside of my marshmallow are getting bigger. So it looks like it's an inverse relationship. As the pressure went down, the volume went up. So now what I'm going to do is I'm going to turn off my vacuum pump. And I'm going to open this up to the air. So nature likes everything to be equal. It likes to equalize pressure. And so as I open this valve to the air, because the pressure inside is lower than the pressure outside, what's going to happen is air is going to rush into my bell jar to equalize the pressure. And so my pressure inside when I open the valve is going to increase again, and so my volume should decrease. So let's look at it. See, it kind of flew and my volume went down. All right, so for each of these gas laws, including Boyle's law, you'll need to know a few things. So let's take a look at our slide here. So you'll need to know the relationship in words. So Boyle's law says that the volume of a fixed quantity of gas is inversely proportional to its pressure at a constant temperature. So again, my amount and my temperature are constant. So I'm looking at my pressure and volume, and we said that the higher the pressure, the lower the volume. So they're inversely related. This should make sense because remember, pressure has to do with particles colliding. Volume obviously is the space that the particles take. So if I have more space, if my volume gets bigger, that means I have less collisions, which makes sense because if the particles have more room to move in, then they're not going to collide as much. So it's an inverse relationship. You also need to know it in terms of like a mathematical equation. So P is proportional. This alpha sign means proportional to 1 over V because it's an inverse relationship. To remove a proportionality symbol, you put an equal and a constant. So you can say P is equal to a constant over V. In chemistry, you use K for the constant. You can also rearrange this to say that P times V is equal to a constant. So if you take the pressure times the volume for a certain gas at a certain amount and temperature, you are going to get the same constant. So let's say that I measured the pressure and the volume of my gas particles in the marshmallow to start with. And so I'm going to call those P1 times V1 because it's the first set of conditions. And that is equal to my constant. Now, let's say I turn on the vacuum pump and my pressure and volume changed. If I take my new volume and my new pressure, multiply them together, I also get K. So I can set those equal to each other, and I can use this equation if I have changing conditions like I had just now in my demo. Another thing you need to know is what would this relationship look like if you were to graph it. So you can see here that if I plot V versus P, because in an inverse relationship, you're going to get a curve like this. If I wanted to make it linear, then I could plot V versus 1 over P, or P versus 1 over V, and then I would get a straight line. So you need to know it in words. You need to know it as an equation. You need to know it graphically, what it looks like. And you also need to be able to do an example. So let's read this example together. It says a gas occupies 22 liters at 2.43 atm. What is the new volume if the pressure changed to 5.11 atm? So as I'm doing this, what I would say is I would go through and kind of label your variables. So a gas occupies 22 liters, so that's like a volume. 2.43 atm, that's a pressure. What is the new volume? Oh, so I need another V, right? So let's go back and call this V1 and P1. This is going to be V2 if the pressure changed to 5.11 atm. So we're going to say, oh, that looks like the relationship between pressure and volume. So it's Boyle's law. So P1 V1 equals P2 V2. P1 is 2.43 atm. V1 is 22 liters. Equals P2 is 5.11 atm, and then V2 is what we're solving for. So to solve for V2, you would take 2.43 times 22 divided by 5.11. Now, before you punch it into your calculator, always make sure that your answer makes sense. So if my pressure is about doubling, what would happen to my volume? Well, it's an inverse relationship. So if my pressure about doubles, then my volume should about half, right? So now punch it into your calculator and see what you get. I ended up with V2 being 10 liters. It should be 266. Your units, ATM and ATM will cancel, and you're going to end up with liters. In this case, the units do not matter what they are as long as P1 and P2 are the same unit and V1 and V2 are the same unit. You can use any units of pressure and any units of volume as long as they're matching.